Alright, so I want to make one more additional video about conversion factors with some problems that are a little different than the ones we've already seen. So we'll start with the first one, which is, let's say we have a square foot, right? And a square foot is 1 foot squared, right? And we want to know how many inches, or square inches it is. And so what a square foot is it's an area, right? Like if you were to measure out on the floor 1 foot by 1 foot, that this area right here would be 1 square foot, right? Whoops. And so a lot of times when people buy apartments or they buy homes, this is they want to know how many square feet the apartment is, and so because that's the idea, right? So and what a square foot is, it's it's where the unit is squared, right? Where this actually means 1 foot times a foot, right? Because if you think back to here, right, that's what you do. Area equals base times height, or side times side if it's a square. And you get 1 foot times 1 foot, which is 1 foot. 1 times 1 is 1. Foot times foot is foot squared. So we're treating our units just like numbers, and we've done this before in math class. So we're doing that here. And now the answer to this question, you might look at it and go, oh, it's 12, right? Because 1 foot is 12 inches, so 1 square foot's obviously 12 inches squared. And that would be wrong. And let's look at why. So we'll start by writing what we have, which is 1 square foot. We then have to get to inches squared. So what we're going to do is we're going to use the conversion factor we have, which is 12 inches equals 1 foot. I want to get rid of feet. I want to get to inches squared. So what you can see is when we cancel a foot here and here, this is just over 1, that you get rid of one of these feet, because there's a foot times a foot here, so you get rid of one of them. So when you cancel here, you get rid of, say, the 2, and you leave it as a 1. So now you just have a foot there. But now if you were and I'll go ahead and write the answer or the numbers in. This is 1 foot, and this is 12 inches. But if you stop there, you would have feet times 12 times inches, and then a bunch of 1s on the bottom, and that wouldn't be right, because then you would get 12 feet inches, whatever the heck that is. So we're going to go one more conversion factor, because we have another foot here we have to get rid of. So we want to cancel that off. And so now I can cancel this foot with this one right here that's left over. And so it took 2 conversion factors to get rid of both of the feet there. All right, both of the units. And so you can see now what's going to happen, right? That we wanted square inches, and we're going to end up getting square inches. So let me rewrite. We are done. We have inches times inches, which is square inches. So I'm going to go ahead and rewrite 1 times 1 times 12. Okay, I get to write that. Times inches. Times inches. And oh, and I forgot my number here. This is 12. And my number here, this is 1. So times another 12. All right, so what we can see then, we multiply this out. Inches times inches equals inches squared. 12 times 12 is 144. Is that 1 square foot is actually equal to 144 inches squared. Okay, so yeah, so not only when you square the units, you also have to square the number as well. All right, good. What the heck is a square inch? A square inch is just an inch by an inch, like that, right? So 1 inch by 1 inch would be a square inch. Okay, so anyways, let's do another one that's similar. I'll just go flip this over. Okay, so we have, let's say we have 1 cubic centimeter. So sometimes this is written as a cc, a cubic centimeter. Maybe you've ever watched like a health show or have been to the doctors and you hear them say cc. Cc is a cubic centimeter, which is equal to a centimeter cubed, right? So that would be what? Well, that would be some kind of that would be a cube, right? That looked like this. That was 1 centimeter on each of its sides. So here, here, and here as well with the height. So anyways, so that would be a cubic centimeter. And now you'd say, well, now it's not area, now it's volume, right? Because when you deal with units that are cubed, you get volume. This is a cube, right? If I was going to try and draw it so it shows that volume, maybe it would look like that. That looks a little bit better. All right, so we got a cubic centimeter. So the question is, how many, we'll say 1 cubic centimeter is equal to how many meters cubed? Yeah, let's give that a try. Is equal to how many meters cubed? All right, so what's our conversion factor normally between centimeters and meters? Well, our equality is usually 100 centimeters is equal to 1 meter. And that really should go in long-term memory. That's something good to know. Okay, so coming back to this. All right, so start by writing what you have. You have the 1 here, so 1 centimeter cubed. We're trying to get to meters. So you can see we're going to do this just like before. Centimeters is going to go on bottom, meters is going to go on top, but we have to do this 3 times, right? Because each time we're going to get rid of one of those centimeters. Because remember, when that says centimeters cubed, that's really saying centimeters times centimeters times centimeters. So when we cancel this one, we make this 2, right? When we cancel this one, we make this 1, and when we cancel this one, we finally get rid of the 1. All right, so we're left with meters cubed on top, but remember, there's numbers that got to go in here too, right? The 100 goes with centimeters. The smaller unit, centimeters, gets the bigger number, 100. The larger unit, meters, gets the smaller unit, 1, because they're equal, so that's kind of like a balancing act. All right, so there we have it, right? So now we can go ahead and simplify or rewrite. So I'm going to go ahead and rewrite it. So on top, I have meters times meters times meters. On bottom, I have, do I have a unit or number on top? Just a bunch of 1s. So if it makes you happy, we can write a 1 up there. On bottom, we have 100 times 100 times 100. All right, so, okay, so I think that's going to be 1/1,000,000th, I think. 100 times 100 times 100. I think that's right. Get the calculator out just to confirm. Yeah, that's going to be 6 zeros, so 1,000,000. So 1/1,000,000th meters cubed, right? So I could write that a couple ways. I guess the most obvious one would be 1 over 1 comma 0 0 0 comma 0 0 0, and my units, meters cubed, is going to go on top. And so that's important to realize that the units are on top there, right, with meters cubed. Another way to write it would be to actually do the math there, to take 1 divided by the answer. I think if we do that, it becomes 0.5 zeros than the 1, right? Yeah, so 1 times 10 to the negative 6 is what my calculator informed me. If I expand that out, though, that would be, draw your decimal point in here, move it 6 times, once around the 1, 2, 3, 4, 5, 6. So you're putting in 1, 2, 3, 4, 5, 5 zeros. So writing it another way would be 0.0000001 meters cubed. Writing it like it was up here, 1 times 10 to the negative 6 meters cubed. So a lot of ways to write that. So we're seeing that a cubic centimeter is very small, right? But since it's a very small unit of volume, it would be a very tiny amount of meters cubed, because a meter is like a yardstick, right? A meter is larger than a yard, so that would be a meter times a meter times a meter, creating this giant box. 3 foot by 3 foot. A little over 3 foot, 3.3 feet by 3.3 feet by 3.3 feet, something like that. I think it's actually 3.28, but whatever. All right, let's go ahead and move to the next problem. So I guess another question that I could do really quick would be, how many milliliters is equal to a meter cubed? So what I'm saying here is 1 meter cubed is equal to how many milliliters? You might remember milliliters from chemistry class, right? You had your 10 milliliter graduated cylinder, which was about the size of this pen, right? If you filled it up with volume, that was 10 milliliters. So how many milliliters would fit in, or would be a meter cubed? Well, you'd have to know another conversion factor here. You would have to understand that a 1 centimeter cubed is equal to 1 milliliter. And so now we can make that conversion. So let's go ahead and give this a try. So we're in meters cubed. If we get to centimeters cubed, we can then use this conversion to get to milliliters. So what I'm saying then is, let's go ahead and do this and go from meters to centimeters cubed, right? So we'll go ahead and do that. Notice I'm throwing the trash on the bottom, which is the meters. It's very similar to what we just did. Numbers there, well, 100 centimeters is equal to 1 meter, right? So I'm going to go ahead and put those numbers in here. So the 100 has to go on top, and the 1 has to go on bottom, and I get to cancel this meters with one of these, so it becomes a 2. To cancel this here, so it becomes a 1, and then this can stay as 100, and this stays as 1. Once again, the 100 here and the 1 here, and then cancel another of these meters off, and finally cancel this one. And so now we have centimeters cubed on top, and now we have one more conversion factor to use. So we have centimeters cubed, centimeter, centimeter, centimeter on top. Let's go ahead and put this centimeter cube. We don't want it, right? It's just a giant fraction party. All right, we don't want the centimeter cube, so we're going to put it down there, and we'll stick the milliliters up here. So, and apparently 1 milliliter is the same as a centimeter cubed. So, did I really need that last one? I guess I could just report out, if I knew the centimeter cubed answer, the milliliter answer is going to be the same. But I just wanted to point that out. So, all right. So, anyways, I'm going to go ahead and cancel now my centimeters cubed with this, and I'm left with milliliters. So I am done. So let's go ahead and multiply the top across, multiply the bottom, and divide. So on top we have 100 times 100 times 100 times milliliters. On bottom we have a bunch of 1s, so really nothing down there. So we have 1, and I think we have the same thing as before, except now it's going to be 1 million on top. Milliliters. All right, so how many liters would that be? Well, just move your decimal from milli. We gotta go 3 spots to the left to get to liters. So 1, 2, 3, it'd be 1,000 liters, which would be a lot, right? You think about a 2 liter of Coke. How many 2 liters then? Well, you can kind of see what I'm doing. I'm doing it in my head, but I just want to show you, right, what I'm doing there by asking those questions. right? I'm saying I'm doing conversions, right? I could have phrased it. Well, how many liters is that? Well, let's go ahead and use 1 liter is 1,000 milliliters, right? And then cancel there. And then say, and then you're left with, we said this was going to be 1,000, right? And then how many 2 liters of pop? Well, obviously 500, right? 500 times 2. And so quite a few 2 liters of pop would fit inside of a cubic meter. All right, so go ahead and write that down. And that's the same as we're saying 1 meter cubed. All right, so if you had a cubic meter of pop, it'd be a lot of pop. All right, let's go to the next problem. So the next problem says, let's go with one more. Let's go with this idea that there's a Greek letter that looks like this, looks like a lowercase p, and it's called rho. And I'm not sure if you've seen it before, but the reason I bring it up is because this is also the symbol for density. So I'm not sure if it's uppercase or lowercase rho, but whatever. It stands for density. And the density of something is how many it's mass divided by volume. So the density of water, right, the rho of water, I'll use it as a subscript, is equal to 1 gram per milliliter. So when you measure out a milliliter of water, you're also measuring out a gram of water. And you might say, well, that's pretty convenient, you know, and because you mass grams and you volume is milliliters. So how is this true? Well, it's true because we set it this way, right? We set a standard for water because it's so useful in something like chemistry or in science, and that we set it to be 1 gram is the same as 1 milliliter. So anyways, the question then that I want to ask is 1 liter of water, could have said H2O, is equal to how many kilograms? All right, so let's go ahead and solve this, and we'll start by writing what we have, which is 1 liter of water. We'll go ahead and go from the bridge I'm thinking here is we know that 1 liter is equal to 1,000 milliliters. So we'll go from liters to milliliters and then milliliters to grams, right? Because this is a conversion factor right here. This is an equality. The fact that 1 milliliter of H2O is equal to 1 gram of H2O. All right, and because that's the density of water. Okay, so we got, these are our 2 equalities we're using. This is how we're going to do it, right? Using these 2 equalities. So we'll start here with this. We'll say that 1 liter of H2O is equal to 1,000 milliliters. Okay, so I can go ahead and cancel off my liters, and I'm left with milliliters. But I want kilograms. So this is only going to get me to grams. I didn't think about that. So I need one more conversion factor. How many grams are in a kilogram? You should say 1,000. So 1,000 grams is equal to 1 kg. It's going to take 3 conversions here to do this. So we need 2 more. All right, so to go from milliliters, we're going to get out of milliliters and go to what? We're going to go to grams, right? So milliliters to grams. Then once we're in grams, we're going to get out of grams and go to kilograms, because that's really what we want to know, right? That was the question there. How many kilograms is 1 liter? So I can go ahead and put the grams down there and the kilograms on top, and then the numbers are going to go for the ride, right? So what numbers? Well, I'm going to go back and look. Here we got grams to milliliters. This was the density of water, right? So we know that 1 gram is equal to 1 milliliter or cubic centimeter. And we also know that 1,000 grams, right, is the same as a kilogram. So we can go ahead and put a 1 right there. All right, let's do our canceling. I forgot to do that. That's my favorite part too. Milliliters cancel milliliters, grams cancel grams. And I didn't write H2O next to all of these, but I could have, like I did there. That's not necessary, but whatever. Okay, so now we can go ahead and rewrite. So on top, so this H2O is gone too. I mean, it's technically there because it's, yeah, we're not, the type of chemical or material we have is not a unit, so I don't really need to put it in there, but it is definitely there. It's water. All right, anyways, so 1 times 1 times 1,000, all right, that there, times 1 times 1 times 1 times 1 times kilograms. On the bottom, 1 times 1 times 1 times 1 times 1,000. And what we can see then, that's pretty cool. 1,000 cancels 1,000, that we're going to be left with 1 kilogram. So if we measure out a gram of water, it was 1 milliliter. If we measure out a kilogram of water, it was 1 liter. And that's pretty cool to know. So there it is. All right, let's do one more problem. All right, for this last one, we're going to work with something called a light year. Okay, so just thinking about that last problem. And so what that says then, if that's true, so if we grab 2 liters of water, if you fill up a 2 liter with water, it would roughly be about 2 kilograms. So in a kilogram is 2.2 pounds, so it'd be about 4.4 pounds. A little more for the plastic bottle, but still, that's what that's saying. So it's kind of neat to think about. All right, good. Let's go ahead and move on. All right, a light year is the distance that light travels in a year. And this is interesting because when you hear light year, you probably think time, right? Because you'd be like, oh, it's a light year, it would be time. But no, it's the distance light travels in that time. So it's kind of a tricky unit to use. Another thing about light is we know it travels at the speed in a vacuum of 3 times 10 to the 8th meters per second. And nothing can go faster than that speed that we know of. You can go slower than it. So light does slow down when it goes through mediums. But in a vacuum, like outer space, light travels 3 times 10 to the 8th meters per second. So what we're going to do here is we want to know, the question is, if light year is a unit of distance. So let me write that down. Light year is a unit of distance. Then a good question would be, well, how many miles is 1 light year? Right? If it's really a unit of distance, how many miles? So what we're going to do here is there's a couple ways to do this, but I think the easiest way is to start by writing 1 year and work with that. So what we're going to do is use the speed of light as a conversion factor. And because if we know 1 year has passed, well, we know in 1 second that light travels this far. But if we can change the bottom to years, right, then we'd know how far it travels in meters in 1 year. So kind of the two ways of doing it is we just convert this from, if this is in meters per second, we just convert it to miles per year. Right? That's really what we're doing, right? We want to know how many miles does it travel in 1 year. So that's another way to look at it right there. But to solve it, you can start by just writing 1 year and converting from time to distance using this rate, using the velocity, the speed. And that will work as well. So yeah, so I don't know if there's a preferred way to do this or the best way to do it. I guess maybe I'll do it both ways. Maybe let's try starting with just 1 year and working off of that. So I think this is the easiest way to see it. So if we start with 1 year and we want to get to we want to convert this into seconds. So I guess they are different because in the other way we'd go with seconds and try and convert it to a year. And this way we're assuming we start with a year. Let's try it both ways. Let's see if this really pans out like the way I'm saying, right? So all right, we start with years and get this to seconds and then use this to flip it into distance. All right, so it's going to look like this. We got to get this to seconds. Well, we know some additional conversion factors that we probably need to add to the sheet that we had last time. Another one is that there's 365.25 days in 1 year. We can use that and then go from days, 24 hours in a day. We can say 1 hour is equal, and if you want to HR instead of just HR is probably better. 1 hour is equal to 60 minutes, and 1 minute is 60 seconds. All right, probably the easiest way to do that. So I'm saying we're from years to days, days to hours, hours to minutes, minutes to seconds. Okay, so let's go ahead and look at that. So we're saying that years are going to go on bottom. 1 year is 365.25 days, right? And we can go ahead and cancel off our years. Now we're in days, so 1 day is going to equal 24 hours. Cancel the days off. Now we're in hours, so 1 hour is equal to 60 minutes. Cancel the hours off. And we'll go again. 1 minute is equal to 60 seconds. Notice we wanted seconds, right? Okay, so now what I'm saying is we can use the rate as a conversion factor. So let me see if I have a different color pen or something to write with here. So I'm saying now, so hopefully this comes through well, or you can see that, you can say that 3 times 10 to the 8th meters is equal to 1 second. And then we can cancel off our seconds. And so we're almost done. We have to get this to miles. So then we can say that we said last time, how are we going to get from meters to miles? I'm going to look at the sheet really quick. We can go from meters into kilometers, and then from kilometers into miles. So let's go ahead and give that a try. So we're saying then that we're going to go, I'm going to go back to the black marker because I only wanted to use that for one, just for you to see where the speed of light is going to come in to convert from time into distance, right? All right, anyways, coming back to this, we're going to say that we're going to put meters on bottom and kilometers on top. So the number that goes with meters is going to be 1,000, and with kilometers is going to be 1. And then we have to go from kilometers to miles, which is 1.609, and this is 1. So now I can cancel these meters, cancel the kilometers, and I'm left with miles. Went from years into miles, just like that, using the speed as a conversion factor. All right, so now we can multiply the top across, multiply the bottom across, and divide. Whoops, sorry, I bumped the table. All right, so let's go ahead and rewrite 365.25 times 24 times 60 times 60 times 3 times 10 to the 8th times miles. I could have drawn MI. All right, on the bottom, 1,000. 1.609. And that's it. All right, so let's go ahead and simplify this, right? Kind of running out of room, so let me get another sheet of paper. All right, so I'm thinking we'll just multiply the bottom across first. Start with 365.25 times 24 times 60 times 60. And then I'm kind of worried about multiplying by that 3 times 10 to the 8th, so I'm going to type in times parenthesis 3EE, right, for exponent. That's times 10 to the, then when I do the EE, and then type in 8, end parenthesis, and I get 9, let me write this down, 9 point, I don't know if you can see it, 46728 times 10 to the 15th. So a really large number, right? Which we would expect. It's a light year, right? Light travels super far in a second. Of course, it's going to travel a long ways in a year. All right, and then divided by the bottom, which is 1,000 times 1.609. That should just be 1609, right? Yeah, so I'll type it in anyways just to prove that. All right, 1609. And so we're going to divide that answer, 9.46728 EE 15, right? We're going to take that and divide it by 1609. And we get 5.88 times 10 to the 12th. I'm going to go one more digit. There's a 3 9, so I'm going to take the 9, round it up to the 3 up to a 4. All right, times 10 to the 12th. And, oh, I forgot to write my units. Shame on me. Miles. Whoops. 5.884 miles. No, times 10 to the 12th miles. All right. Is that the same as I would have did it the other way, right? Let's check the other way really quick then, and but you can kind of see how it works out. So quite a few miles, right? 5 884 followed by 9 more zeros roughly, so quite a few miles. Let's go ahead and check the other way. So the other way I was suggesting you could try, if you don't like that way, is that you start by writing 3 times 10 to the 8th divided by 1 second, right? And then you change this into let's see, into miles per year, right? So you get the bottom to be years and the top to be miles. All right, I'm gonna probably need to write this. Maybe I think I have enough room here. I'm gonna write it smaller though. What do we want to convert first, the top or the bottom? Doesn't matter to me. I'm going to do this faster though, just because it is my second time through the problem. Let's go with the bottom first. That's what we did last time, right? And so we want to go from seconds into years. Okay, so 60 seconds is 1 minute. Notice how I wrote it, right? Because I want to cancel my seconds and change the bottom. I want to get it to be years. Okay, we're in minutes now. 60 minutes is equal to 1 hour. Cancel those minutes away. Now we're in hours. Got to get to years, so I'm thinking hours to days. I'm thinking we'll go hours to days and then days to years, like that. All right, and so let's go ahead and plug the numbers in. 1 day, 24 hours. Days, 365.25 days is 1 year. And you can see I can cancel now. Hours on top and bottom, days on top and bottom, and I'm left with years on bottom. All right, so we're halfway there, right? Let's get meters into miles now. So to get from meters to miles, we'll do something similar. Notice I'm going to cancel long distance so top to bottom, right? So I got to have meters down there. We'll go meters to kilometers, and then we'll go from kilometers into miles, right? Okay, so meters to kilometers, what were the conversions we said last time? 1,000 meters is 1 kilometer. Notice I can cancel now because this was one big fraction party, right? See, I can just draw this line all the way through if I really want. One giant fraction. All right, so then I'm in kilometers, and I can now cancel my kilometers right here, and I'm left with miles, but need numbers here. 1.609 kilometers is equal to 1 mile. All right. So that's it. Now let's go ahead and we're in miles on top, miles per year. So let's go ahead and rewrite now. 3 times 10 to the 8th times 60 times 60 times 24 times 365.25 times miles divided by years. 1,000. 1.609. Does that look the same as last time? Let's go back and look. Put those two side by side. Do they look the same? Let's see. So this was last time, right? 3 point. Kind of order is different. Those two are flipped, but the order doesn't matter when you multiply. It's all on top. All right, on bottom is 1,000 and 1.609. So it's exactly identical. Hopefully you can see that those two are identical, right? This fraction is identical to this fraction. So if we do the math here, we're going to get the same answer, which is that, where is it written? Right up here, right? That 5.884 times 10 to the 12th. And that's going to be miles per years, right? But don't forget on bottom, right? When we write that year down there, there is a 1 there, right? Because we took this number and took this number and divided by this number, and it leaves us with a 1 on bottom. So that's how many miles are in 1 year, and that's it. All right. And if there's, hopefully that's making sense, and that's definitely a little tougher problem, but that's why we do this problem mainly in honors physics. But yeah, that's fun. So light year is a distance unit, not a time unit. All right, that's it.